All right, so this is an interesting problem over here. Again, even the starting number is interesting. I mean, why is he starting there? And let's write this down for you. It looks kind of strange, but if I wrote this down, it's going to be 1 over the natural log of 1619, and that's going to be raised to a power of the natural log 1619. And then you go to the next term. I don't write too many down, but I start to realize, looking at it, natural log, that's going to be 1620 now, raised to the natural log 1620. It's even hard to write down. But again, what do I know about this is a positive term series where you're decreasing. When I go on looking at it, and the question is, it doesn't look easy to deal with. And so the thing I would look at over here, and I want to go through it with you, is kind of rewriting things. And someone says, why do you want to rewrite things? I got a natural log of n raised to the natural log of n. I just want to kind of rewrite it so it looks a little bit more familiar to me. All right? So the way I did that was I certainly wrote down the bottom. This is the bottom, by the way. And then I started, writing down in terms of e, right? So I just want to talk about this over here. And this is going to be, e, natural log of the natural log of n. And certainly you should know that's going to give you the natural log of n. So really nothing's changed there, all right? Nothing's changed there. And then, you might say, what'd you do now? I use rules of exponents. Let me erase this over here. I'll tell you what I mean by that. So a raised to the m raised to the n is going to be the same thing as a to the n raised to the m. All right? So that's all I did over here. I commute the exponents around. That's natural log of n. I put it here, and I put this on the outside. All right? Then, I'm looking at something that makes it a little bit easier for me to deal with, and I'll tell you what I'm looking at now. I'm looking at e to the ln n, and what's that give me? It just gives me n, and that's where this is coming from over here. So kind of looking at it, and you might say, I'm still stuck, I don't know what to do there, but I got to think about it, and that's always the problem with this one. Again, I thought this was a tough problem. I thought it was tough, a bit tough. Like for number 4, I wouldn't have put this down. But then the question comes is, and you might have to use a calculator to do this, by the way. I looked at this over here, n, and that's the natural log of the natural log of n. I looked at that, and as n goes to infinity, and I kept looking at it, and I kind of wondered about that. And when I wondered about that, it had something to do, it looked like n to some power. I'm going to put this over here. All right? Now, before I do anything, really what I'm doing, and the bases are the same. This base here, that base is the same. I'm really looking at the powers. All right? So what am I looking at? I'm really looking at the natural log of n compared to the 2 over here. All right? And what I'm going to claim over here is that I'm going to claim that this is going to be greater than 2 for some value of n. All right, for some value of n. And this, to be honest with you, this is where I use the calculator. And I do recommend you do that, by the way. Look at a calculator, and you start playing around with it. And this is going to be true. This will be true if the n is greater than 1618. All right? So that's why they started at 1619, because this becomes true at 1619 forward. So what I do over here is, if this is true, right, looking at this over here now, for these numbers over here, I got a relationship now. And what's the relationship going to be? Let's write this down now. I'm going to put a symbol between, I'm looking at this now, I'm going to put a symbol between these guys over here. And the symbol I'm going to put down is this over here. Let me point out why I'm saying that. This exponent is going to be bigger than number 2 once I hit that number over there. Well, if that's true, I'm going to do the reciprocal. And what do you get over there? 1 over the natural log. I'm sorry, I need to say that. I'm going to erase that. 1 over n to the natural log ln n is going to be less than 1 over n squared. Well, someone says, gee, that's nice because I know something now. And what do I know? Well, I know the terms, and they're positive term series, by the way. I know, like, for example, I'm looking at this sum over here, and let me just start this, n equals 1619 off to infinity of 1 over n squared. This is definitely convergent. It's convergent p-series. It's convergent. Now, what do I know about this? The sum of this thing has got to be less than the sum of this thing. I'm sorry, greater than the sum of this thing over here. n equals 1619 off to infinity, and that's going to be 1 over n ln n. That's hard to jam that in there, isn't it? And what do we know about this one over here? Well, we just went through it. This one's identical to this one over here. N equals 1619 off to infinity of 1 over ln n to the ln n. All right? So what about the series then? It's convergent. This is convergent. Thank you.